Hi, I'm Alon Cohen from OCZ Israel, and we are here to demonstrate to you today empowering the virtualized data center with the Z Drive R4 and the VXL software. What we have set up here today for you are the complete components of the data center. We have two ES6 servers. These are configured as a VMware cluster running virtualization software that can run multiple virtual machines in the same physical environment. We also have SAN, a storage area network, the DS3400 in this case, which is connected via fiber channel to these host machines. On one of these host machines, we have installed a Z Drive R4. The VXL software will take this Z Drive R4, dynamically distribute it to any virtual machine within the environment that needs it, and accelerate the data towards that virtual machine. To demonstrate this, we will now connect to one of the virtual machines within this environment. We will use a virtual desktop connection. That will allow us to look at the I/O patterns from within the virtual machine. We will start a test load using the I/O meter load simulation software. As you can see, I/O has just started occurring from the virtual machine through the hypervisor layer, going directly towards the DS3400 SAN storage. You can see that before acceleration, we have reached about 40 or 42 megabytes per second, which is not untypical for I/Os going from a virtual machine through a virtualized environment towards remotely accessed storage. However, as we have the Z Drive R4 and the VXL software installed, we can now turn to our VXL Storage Pro management system, which allows you to monitor all those volumes that you have within this virtualized environment and allows you to select what type of acceleration you want to deploy for each and any of the virtual machines and volumes within this environment. We will select the volume that we are now working on and tell the system that we want to accelerate this virtual volume. We press the acceleration button, and we can see that we now have an indication for the IT manager that this volume is now being accelerated by the VXL. We will turn back to our virtual desktop to see the effect of that acceleration. The VXL is a caching system, which means it will now monitor the I/O as it goes from the virtual machine towards the SAN storage, take a look at whether this is data that is worth caching on the Z Drive R4, and if it is, move it towards the Z Drive R4. As mentioned previously, this is a dynamic caching capability, meaning that the VXL is identifying that this virtual machine is now requiring more I/O, and it will therefore allocate a larger and larger part of the Z Drive R4 flash towards that virtual machine. It will also move the data from the underlying storage to the flash, enabling a much faster access towards that data for the virtual machine. You can see that we have now reached about double the performance that we were before, and we continue to grow in performance. The performance is getting quicker because the flash is both a lot faster than the HDDs, the physical hard drive, but it is also faster because the flash is now located a lot closer to the virtual machines which are running on this host machine. So the data path that now the system is using to gain access to its data is moving from the virtual machine through the hypervisor to the flash that resides on the same physical system. The flash is answering a lot quicker, and obviously our performance is increasing. Flash is therefore an enabler for virtualized environments. I/O patterns that would limit the amount of virtual machines that you can place in a virtualized environment can now be placed in this environment because it has flash on a Z drive R4 installed within this environment, and because the VXL can distribute that flash efficiently to the virtual machines. We see that through acceleration, we have reached a point that we are now at more than 10 times the performance that we were before for these virtual machines, running at above 500 megabytes per second from a virtual machine within a hypervisor environment. One of the main advantages of virtualized environments is the capability to move virtual machines between physical hosts. And we want to show you that the VXL not only can accelerate, but can also retain this acceleration and retain the cache data while virtual machines are migrated using vMotion between physical environments. We will turn now to the vCenter, which is the VMware management station, and as you can see, the virtual machine that we have now run this I/O from is residing on physical host 210, which is the physical host that is the top one in this environment. We will tell VMware to migrate online using vMotion to a different host. As you recall, we were on host 210, so we will tell it to move to host 200. We will give this high priority and start the vMotion process. You can see that the vMotion process has started down here, and I will put these two screens together so that you can see that as this vMotion process is occurring, I/O is still going through the system. At this instance exactly, VMware has moved the virtual machines between the two physical hosts. We are now running on physical host 200. The virtual machine is using more CPU power from this virtualized environment, but as you can see, the performance retains at the high level of acceleration. The VXL enables achieving this by turning the local connection whenever there is a vMotion present to a remote iSCSI connection, allowing the virtual machine to access its cache data wherever it resides within this virtualized environment. In essence, the VXL software allows you to take all the power of PCIe flash on the Z drive R4 and make it available to virtual machines throughout your environment wherever these virtual machines reside.